What's up? Alright. Okay, so this one is this problem. So that's a DC voltage. Da-da-da, you have another MOSFET here. Then you've got one linked like this. Another MOSFET here. You have a random DC voltage here. Not really voltage, I think, but anyway, input voltage here. And you have this link to another MOSFET circuit here, attached to ground. And there's a V out here. Oh my gosh, that sucks. And you have another MOSFET here. VCC there. So I'm going to label all these MOSFETs like they were in the problem just to make this a little bit more clear. It's MOSFET 1, MOSFET 2. Now, usually when so the goal of what we're going to do on this problem is we have this, we're going to call this VA. And our goal is we want to find VA in terms of VN and then VOut in terms of VA. That's our main goal for this problem. So what I'm going to do first is I'm going to actually, to make this more clear, I don't usually do this on a test, but to make this more clear, I'm going to divide this into two different circuits. Because we got to worry about the input impedance of this and the output impedance of this. Actually, we don't have to worry about that for this one, but I also want to show why we don't have to worry about the output impedance of this. Because that's actually not super clear. So I'm gonna divide this into two circuits first. This is gonna be kind of slow, but draw it again. I'm not gonna draw these things faster. Okay, so this node right here, I'm going to label it VA. And so there's a resistor right here, which is we'll call the input resistance of the right section, which is just this like what you see into this part, like it's this input impedance right here. I'm just going to recall that Rn of right piece. And then we're going to have, I'm going to do that again for the left side. So what you have is another resistor called, this resistor you don't actually have to worry about it, but I want to show why. Rout of left piece. Da-da. There's VAR there. So I'm just drawing the left chunk of this part. I got this. So when you're here, it's pretty clear to see that this resistor is in parallel with the input resistance of M2. And you could, does that make sense to everyone? I could draw the small signal model for that, but it should be pretty clear that this input resistance is in parallel with this input resistance. All right, but it's actually, like this is pretty intuitive to see, but it's actually not super clear why this resistor doesn't affect anything in this circuit. And the reason why, I'm gonna have to draw a small signal model to prove that real quick, but like you don't actually do this on the test, but I just want to show why real quick. So this is that resistor of left piece. And then there is this thing, and there's a current source, and then there's the, oh by the way, for this problem, we have that, whatever that sign is, I still don't know what that is, this thing. It's not equal to 0, so we're gonna have to worry about this. This resistor. And then you have this, which is the drain resistance. There's actually input resistance of that, but and you have V out here. And then you have a Vn at this point, which we'll call VA. Not really more clear, but. And you can see, because there's no current here, VA is already decided, so that's our input voltage. So V is already decided, and there's no current here, so V out is not going to be affected by this resistor at all. So we don't even have to worry about this resistance when we're finding like a gain from VA to V out. So that's why we can just cut that out and not worry about that. Actually, at the end of the problem, actually realize you don't have to worry about this either, but you don't know that yet. So now what we have is now we have all that information. We need to find all the input impedance, all of that. So we need to find 3 of them. The first one we're going to do is we're going to find the input impedance of M2. So okay, I'll go over here. So first step, let's find the input impedance of this. Da-da. Okay, so I noticed something that a lot of you might think that, well, at least I thought this at first, but a lot of you might think that with the source and gate grounded in this small signal and looking to the drain, you might think this is a common source, like this might be the RL of a common source when you look at your flashcard, but it is not. And the reason why it's not is because you cut this part out. And this is the thing that biases it, okay? And that is why it is not that topology. And I think a lot of you might be still confused why, so I could draw a small signal to prove exactly why this is. Want me to do that?
Yeah.
No? Yeah? I think I'll do it real quick. It's not that bad. So this is a small signal for a common drain. Da-da. We could cut out this because there is no voltage drop across here because this is 0 volts. 0 volts, so we cut that out. So then you just have this R0 RO2 thing, and it is in parallel with a drain resistor. And you can see pretty clearly that these two are in parallel. But when you cut this out, when you even remove this part, it's a different topology, right? So because does that make sense now? Because this is completely different when you cut this out. It is not the topology on your flashcard. But I mean, it's pretty much the same process to find it out. Like, so basically what you gotta do is you gotta draw a small signal model when it's not on your flashcard. So I just did that, and you can pretty clearly see that it's like you have input voltage and it's like all the way ground. This is just basic. It looks like this. When you take this current source out, it pretty much looks like this. And it's pretty easy to see that the input resistance is R02 for that thing. So that means we can replace that with that. But I'm just going to write this here, and we can do all that later. So this is the input resistance of M2. So that's one of the 3 input resistances that we have to find. So now, well, the rest of these are pretty easy. Like the next part is now we've got to find this one. So we basically got to find the input resistance of this. I'll call it M4. And the input resistance of that is on your table. It's one of the miscellaneous circuits. Oh man, he's asleep. Anyway. So we'll call it Rn of M4. And it is, I believe, from your table this. Da-da. And now, one more thing we gotta do is because this input resistance is in parallel with this input resistance, we've got to find the input resistance of this guy. So actually that one is, I believe, again in your table. Let me take a look. Oh yeah. Okay, so I'm gonna redraw the right chunk with this input resistance that we found. Because we found an input resistance of this. I can replace that with a resistor now, which is great.